Hey everyone, welcome back to my another second tutorial where I'll try to write code to visualize an elegant Bitcoin reinforcement learning trading agent chart using Matplotlib. I'm going to extend the code written in my previous tutorial to render a visualization of my agent. And if you haven't read or watched my previous tutorial and you're not familiar with the code, I recommend first to check it out, read it, watch my video, and only then continue with this tutorial further. If you are unfamiliar with the Matplotlib Python library, don't worry, I'll be going over the code step by step so you could create your own custom visualization or modify mine according to your needs. If you can't understand everything, as always, this tutorial code will be available on my GitHub repository. So before moving forward, I will show you a short preview of what we are going to create in this tutorial. So I'll open my folder. I have already created all the GIFs, so I'll open the GIF of our final results, what we would like to see. So as you can see, it shows the prices, open, high, close, low, where we do our orders, our balances in a blue line, and so on. So this is the elegant chart what we would like to create for our environment actually. So I'm not going to show it all the time. And at first look, it might look quite complicated, but actually it's not that hard. It's just a couple of parameters updating on each environment step with some key information with the help of Matplotlib already written functionality. So let's begin. In our last tutorial, we wrote a simple render function. I have it somewhere here, using print statement to display the agent's net worth. Also, I could have added other important metrics, but I left them to this tutorial. So let's begin writing that logic to a new method file called utils.py. As you can see, I already made this file. So first, what I'll do, I'll write a short code to save our sessions trading metrics to a file. Of course, if necessary, I'll begin creating a simple function called write to file. And I already did this. I wrote a write to file function, and what it does, so it will create the txt file name, and I'll name it with a current date formatted. And we should feed it with a date and net worth will be parameters list, which will print to a file. As you can see, it creates a file called logs, and we'll put a txt file into that logs file. And if I'll copy this write to file, I already imported this into my code. So first, what we should do, we should import it. So I already have imported my trading graph and write to file, but this is next part of this tutorial. So write to file is here, and I use it. So let's try it out and run our random agent for a few games for one episode. Let's build it. And of course, what I should say that as you can see, I feed a date and self orders history, the last appended step. So we could use this whole line to copy it here, something like this, or I simply chose to use already appended history, the last array of that list simply. Okay, let's, as I said, where's my reset? Okay, let's build this. And as you can see, my net worth was around 0.37 of in average of our random games, and here the file was created. I can run another one, and now our average net worth is negative. So simply let's open one of them and let's see what we can see. So as you can see, this is our all orders we do, and we do all buy, sell, or whatever, it doesn't matter. And the first thing what I noticed when creating this following printing to file function, that my balance doesn't go to zero actually. And as you can see, it goes to some kind of very close number to a 0. And here came the first problem, because I set to make a step, for example, by if my balance was more than 0. As you can see, I already changed it, so I only make orders if my balance is more than 1% or larger. My balance is larger than 1% of my initial balance. So that's quite it. And that's it. I simply used this for debugging and checking if it actually does orders and how my balance changes after sell, buy, or even hold step. And that's it. As you can see, here was 3-4 steps of holding and my balance was not changing and so on. And this is actually all the same history what my trading bot sees. This is 50 steps, for example, and that's it. Okay, I'm not holding you here, so let's move forward, and I'll begin with what I changed in my code. And here is my custom environment, and what I added is render range, as you can see, and this means that I'll render 100 bars in a history in my chart, and then will be a moving bar. So I'll first in, first out goes. That's it. So I'll insert this quote line, then I go to reset. Here I declared a deque and visualization. So here we create our trading graph object class, and this is the main function where we do our implementation. So here I tried to make as less changes as possible, and I'll just mention these here. So this is our trades. It's limited orders memory for our visualization, which will send it to them. So next we go to a step function. And actually, we would like to know what is the current date, high and low of our current bar. So I need to declare this also for my visualization. And the last thing that is when I do an order, sell or buy, I append this to my self-trades dictionary. And of course, I will also use them for my visualization. Next, let's go to a render. So before there was a print statement, and right now we'll use simply all the parameters needed: date, open, close, high, low, volume, and net worth, and trades, and so on. And that's actually it, I think, for my render and other implementations. And actually what I wrote that will use something like true to visualize our agent. For now I'll leave it for a false, and this is used in our random and in our render. So we can, if we visualize, we will render everything. If we won't, so actually we won't. That's it. Now I think we can move to our trading graph, and here is the all necessary imports libraries for our graph. We'll define our trading graph and its init method in this file actually, and this is the file where we are creating matplotlib figure and set up each of the subplots to be rendered. First, we are defining some deque list where we'll save our temporary information for our graph. This is the place where I create the first look of our graph by defining style and figure size. Also, I'm closing all plots in case they are open. This is necessary when we want to start running the second episode graph. And agent resets and reinitializes every episode. So actually, this it's a must. What I can say that I'm creating a figure of size 16 by 8, and as you can see, we use a plt subplot to grid function, the method to first create a main subplot at the top of our figure to render our market candlestick data. And then we create another subplot below it for our volume. And the last, we create the third axis with twin-x function, which allows us to overlay another grid on top that will share the same x-axis. The first argument of subplot to grid function is the size of the subplot, and the second is the location within the figure. And I set following them. Usually when we are plotting some kind of graph with Matplotlib library, mostly there are large white margins that makes our graph smaller. It's recommended to remove them. Until now I used a subplot adjust, as you can see, this line function, but I found that tight layout is much better. We don't need to measure our white margin sizes. Also, it's necessary at this point, but our chart with labels on sides looks much better, so I set the date price balance axis, not forgot doing that in the future. Finally, and most importantly, we will render our figure to the screen using plt show. So as you can see, I commented this actually because I'm using this, so I actually could remove this, but I wanted to add this as a choice for you. And of course there is self-date format. I'm not sure why it's duplicated here, so I actually could remove one of these lines. So that's it, I think. And okay, I'll save it, and actually when I run this, plt should render. So this is the first look of our plt show figure. Next, let's write our render method. This will take all the information from the current step, time step, and render a live representation to the screen. One of the most complicated things is rendering a price graph, but luckily, to keep things simple, we can use OHCL bars from MPL Finance library, and I imported, and this is actually at the top of utils, this one. And if you don't already have it, simply write pip install MPL Finance, as this package is the easiest way for the candlestick graph to be plotted. The d2num function is here in render function. d2num function is used to reformat dates into time steps necessary in the OHCL rendering process, and every render step we append our necessary OHCL data to DQ memory, which is rendered on our plot. Because our graph is dynamic, we must clear the previous frames before rendering a new one. So we use AX clear, and actually we must clear the previous frame before rendering a new one. After doing so, we take the OHCL data and render a candlestick graph to the self AX1 subplot, actually here. So I'll comment this one, and yeah, we can, that's enough for now. And actually I'll need to comment this, this, and this, and this, and we use them here. And because we are clearing our all axis every frame, our labels are cleared also, so we move them from init, as you can see right now, I commented them, to render part. Finally, and most importantly, we will render our figure to the screen using plt show, and I use block equal to false. If you forgot to pass block equal to false, you will only ever see the first step render, after which the agent will be blocked from continuing. It's important to call plt pause, otherwise each frame will be cleared by the next call to render, before the last frame was actually shown on screen. So actually I just need to set true as the render in my primary file, and it actually should work. And I would like to comment writing to file. Where is my write to file function? Because I'm not using it now. I just showed you as a choice for you. So actually I implemented the candlesticks, which I can show you. and let's simply run our bot. So as you can see, it's quite easy. So the hardest part was done already. Now we would like to add volume and net worth and beautifully formatted dates to our plot. To do so, the same as we did with our OHCL data, we should collect volume and net worth history data by appending them to the DQ list. In the same manner, we clear AX2 and AX3 subplots. We put all dates to the one list and fill AX subplot with our historical volumes. So I close this, I don't need this. As you can see, it interrupts my work. Cancel build. So I move back to my utils. And right now I would like to uncomment all of these lines. I mention it. So this line will add a volumes. So we set clear layer, and here we collect all the date render range. So this is a short function, so I just collect the dates from my history. So I uncomment this and this. The most important lines are this kinda: set major formatter and auto fmtx date, where all the beautiful date formatting is done. To add net worth is one of the simplest parts. We simply add the following line to the AX3 plot, and we simply add the self net worth, color blue of course, and so on. So actually this is quite simple, and this only takes me time to explain, but nothing more. So okay, I can save it and let's run it again. Okay, I have here some kind of problem. Yeah, some misunderstanding. Yeah, I need to uncomment this, because every render range we append a volume and net worth to our history. So that's it. Of course, we add render data, also all the information from here to our history. So let's run our bot. So as you can see, now our chart is quite informative. There are many ways how I could improve it, but at this point we mostly would like to know where our orders were made. So we need to add some kind of arrow points, I think. And to find how to add beautiful red and green arrows to our plot took me a while. But finally, I found a commonly used plot type, scatter plot, close cousin of the line plot. So instead of points being joined by line segments, here the points are represented individually with a dot, circle, or other shapes. This is the place where we'll use our self-trades definition dictionary from our main program. This place might be a little slower because I'm using for loop to find date position where our orders were made in plot history. So let me cancel the build, of course. Cancel build, I don't need this. Let's move back to my utils, and I already written everything here. I should simply uncomment these. So according to the order type, I put the green or red arrow, and now code looks quite simple here. So here is my green arrow, and here is a red arrow if there is by, or if there was else cell. So I use a red arrow. So this is quite simple, or it looks quite simple. And also you might see that I will comment this part. I'm not using this anymore. Because as you can see there, it was interrupting my work. We can't continue write a code or minimize it or do anything typing with our keyboard. As a workaround, I found that the best solution is to use the OpenCV library, and actually there is a final beautiful visualization code finished for my trading bot making an actions, actually to record the this tutorial video took much less time than creating all of this, implementing, testing, joining, making the code look understandable and beautiful, and so on. So actually that's it. I think I can run it again, and let's see how it looks. And right now, as you can see, it works a little slower, but what we can expect when we are visualizing everything. And when we will train our agent, we won't visualize it. We only use it when we would like to see how it actually performs, how it works, and that's it. So that's my idea. And now I have a beautiful live rendering visualization of our random Bitcoin trading environment I created in the previous tutorial. We still haven't put much time into teaching the agent how to make money, and of course we'll do that in the next tutorial. We did a huge job already here. Now when we'll have our trained agent doing some specific actions, we'll be able to evaluate if these actions were better than random or they weren't. And that's it actually. This was a quiet review of my code, and of course, as always, all the code given in this tutorial will be found on my GitHub page and is free to use. So see you in the next part where we will add some neurons to our agent, and I'll try to make some kind of training. And of course, for more details, how to implement and how everything step by step works, you can check on my text version tutorial. So thank you again. Subscribe, like my video if you liked, or share. Doesn't matter. You will help whatever you do. Just follow me. So see you in the next part of this tutorial series. Goodbye.